Good evening. This is the presentation for DCC401142 Steel Structure Design. Introduction. Steel structure design introduces the fundamental principles and application of designing steel structures that are safe, strong, and efficient. The course provides students with a clear understanding of how structural steel is used in buildings and infrastructure, focusing on the behavior of steel under different loading conditions. It highlights the versatility of steel as a construction material and its role in modern engineering design. Students will explore the design of key structural elements such as beams, columns, and connection using Bureau Code 3 MSEN 1993. Emphasis is placed on strength, serviceability, and economy to ensure that structures meet safety standards while remaining cost effective. The course bridges theoretical understanding with real-world application through practical exercises and design projects. Next is the course objectives. The main objective of this course is to equip students with the knowledge and technical skills required to design and analyze steel structures according to the current engineering standards. Through these subjects, students will develop an understanding of the mechanical properties of steel, the design philosophies of limit state design (LSD), and the principle of safety and serviceability. By the end of the course, students will be capable of designing structural members such as tension and compression elements, beams, and connections. They will also learn to apply design codes effectively, interpret structural drawings, and ensure designs are both economical and safe. This course prepares students for professional practice in civil and structural engineering environment. Next, course content overview. There are seven content. First one is introduction to steel structures, material properties and load types, design of tension members, design of compression members, design of beams, design of connections, and design of base plate and portal frame. Moving on to the introduction to steel structures. A steel structure is composed of interconnected steel members that resist applied loads through tension, compression, and bending. Applications are such as bridges, factories, towers, high-rise buildings, and warehouses. The advantages is high strength to weight ratio, prefabrication, rapid construction, and recyclability. While disadvantages, prone to corrosion and fire, requires protective coatings and maintenance. The design aim is to achieve a balance between safety, economy, and structural integrity. Next is the design philosophy. The design process follows the limit state design (LSD) method. There are two key limit states. First one is ultimate limit state (ULS) that ensures the structure will not collapse or fail under maximum load. Second one is serviceability limit state (SLS). It, it is to ensure the structure remains functional and comfortable to use, no excessive deflection or vibration. Incorporates partial safety factors like YF and YM to account for uncertainties in material strength and loading. The LSD method ensures both safety and usability throughout the structure's lifespan.
Representing about the material properties of steel, yield strength Fy, the stress at which steel begin to deform permanently. Ultimate strength Fu, maximum stress steel can withstand before the rupture. Modulus of elasticity E equal to 200 GPa represents stiffness and resistance to deformation. Density is 7,850 kgm3 influencing dead load calculation. Ductility allows deformation before failures, providing warning before collapse. This property ensures steel structure perform reliably under various conditions. Next is load types and combination. There are few types of load. The first one is dead load, is permanent weight of the structure and fixed element. The second one is leaf load. These are the variable loads from occupancy, furniture, and vehicle. And the third load is wind load, which is literal pressure acting on surface. Next is seismic or snow load applied in special condition. There are few types of load combination. So first, safety loads that are multiplied by this factor. So these are the example of load combination. And proper loads combination ensure the structure remains safe under worst case scenario. Next is design of tension members. Members carrying axial tension include truss ties and bracing system. So these are the design procedure. First is calculate the gross area and net area after bolt hole. Second, determines the design strength. So these are the equation for the design strength. Third one is check for failure modes, yielding rupture and block shear. Common section angles at flat plates road. Design must ensure members can resist applied load safely and efficiently.
Now we move on to the design of compression member. Compression member like column and struts carry axial compressive load and the main failure mode is buckling. The design steps are calculate the effective length using LE K multiply L, which means we multiply the K factor by the actual length L. Number two is compute the slenderness ratio. LE divides R, where we divide the effective length by the radius of gyrations. Number three is apply the buckling radiations factor to adjust the strength for buckling effect. Number four is find the design strength using PDX multiply Fy multiply Ag, meaning we multiply X the yield strength Fy and the cross-sectional area Ag. Proper design ensure the compression member remains stable and safe under vertical load. Next, we look at the design of beam. Beam are structural members that resist bending moment and shear force caused by transverse load. For the design check, number one is bending check. We compare the applied bending moment MD with the design bending resistance MRD. The goal is to ensure that MED is less than or equal to MRD. Number two is shear check. Some media will ensure that applied shear force VED is less than or equal to VRD, the design shear resistance. Number three is deflection control. We check deflection limit to make sure the beam doesn't not bend too much under service load. Number four is lateral sectional buckling. For long slender beam, we ensure that beam has enough stability to prevent twist or sideway bending. Common Common sections. Next, we talk about bolt connection. Bolt connection are widely used to assemble structural member because they are easy to install, dismantle, and inspect. There are two main types of bolt. Number one is ordinary bolt, which are used for general applications. Number two is SSFG bolt, which are high strength friction strip bolt used when higher performance is required. For the design check, we check shear capacity, bearing strength, and bolt tensions to ensure the bolt can safely carry the load. Number two is we also check the minimum edge distance and spacing so the plate doesn't not tear or fail around the bolt. Overall, proper board design ensure efficient load transfer and safe performance for of the condition.
Okay, next, my name is Vanessa, and okay, for next slide is welded connection. First is provide permanent and rigid joints between members, and then types of weld. First is fillet welds, join surface at right angles. Second is butt weld, join align surface end to end. And then design considerations. First, determine weld through thickness. Second is check stresses due to shear, tension, and bending. And then weld quality inspection is essential to prevent failure. And lastly is commonly used in steel frames, trusses, and base plates. Okay, in this slide, which is two design. First is base plate design. Base plate design is the base plate transfers column load to concrete foundations. Design requirements. First is adequate plate area to distribute load safely. Second, plate thickness to resist bending stress. Third is proper bearing on concrete. And next is design of anchor bolts for tension and shear. And for objective is ensure safe transfer of loads and stability of the column foundation connection. And the next design is photo frame. Photo frame is a rigid structure commonly used in factories, workshop, and warehouse. For photo frame is for the components is columns, rafters, houses, and knee joints. Design step first is analyze frame under dead life and one load. Second, determine bending moment, shear and axial force. Third is check deflection and sway limit. And for advantage is economical, lightweight, easy to erect, and provide large clear span. Okay, and lastly is conclusion. Still, the structure design is one of the most essential subjects for civil engineering students. It combines theory and practice to help students understand how to design safe, strong, and cost-effective structure. Throughout this course, Through this course, student learn how to still behaves under various loading conditions and how to apply design standards such as Eurocode 3 to ensure structure integrity. The knowledge and skills gained from DCC 40142 will prepare students for future professional work in the construction and engineering industry. Mastering the design of beam, columns, connections, and frame enable graduates to contribute effective to the creation of durable and sustainable infrastructure worldwide. That's all. Okay, that's all from our group. Thank you.